Now we're going to look at volume of prisms. We're going to start by introducing volume. We're going to identify prisms. We're going to look at volume of square and rectangular prisms, then volume of cubes, volume of rectangular prisms, and then trapezoidal prisms. So the volume represents the amount of space a three-dimensional object occupies. It typically refers to capacity of a three-dimensional object. The units are in cubic units, which means you multiply the unit 3 times, so it's cube. And then the formula for volume is area of the base times the height. And the height of a prism is the line that joins the bases together. So let's look at a prism. Prism is a solid object with identical ends, identical bases. They have flat faces and they have the same cross section along its length. So let's look at the length here. So what it's saying is cross section. If I cut a cross section around here, I should see a square. If I cut a cross section around here, I'm going to see a square. If I cut a cross section around here, I should also see a rectangle, and a cross section here should be a triangle. So anywhere along the length, you should see a shape that represents the face. So that's really what that means. Cross section here, cross section here, cross section here. So that's really what that means. And then a prism is identified by its base. So a rectangular prism means it has a rectangular base. A square prism means it has a square base. A triangular prism means it has a triangular base, and so on and so forth. Let's look at square and rectangular prisms. So a square prism has a square base and a rectangular prism has a rectangular base. Now the volume is going to be area of the base times the height. So we're going to look first we're going to determine the base. The base here in a rectangle is going to be, the area of the base is length times width, and then you multiply it by the height. If it was a square, it will be side times side, and then you multiply it by the height. So let's look at this example here. What is the volume of the prism below? So let's look at, we're going to first try to cut a cross section here. So you can see that everywhere we cut a cross section, we have this face right here. So it's going to be area, so the volume is area of base times height. The area of the base is 4 times 4, and then the height is that line that joins both bases together, which is 6.5. So 4 times 4 is 16 multiplied by 6.5. This is going to give us 104 cubic inches. What is the volume of a square prism? A square prism with a base length of 8 and a height of 12. So volume is area of base times height. The area of base is 8 times 8. The height is 12. 8 times 8 is 64, and then you multiply by 12, which will give you, if you multiply 64 by 12, you will get 768, and then we have cubic centimeters. So a cube is a unique type of prism because it has a square base, but also the height is the same length as the height of the cube is the same length as the side of the face of the cube. So here we look at this right here. This is a square base, but then the length is also a square. So here we have area of the base times height. So the area of the base is side squared, and then the height is the same length or has the same length as the side. So you have side cube. Now, what is the volume of the prism below? So we see that we have a square base, and then we have the length of the height is the same as the side, one of the length of the side of the square. So the volume is going to be side to the power of 3, which is 5 centimeters to the power of 3, which is 5 times 5 times 5 cm cube. This is going to give us 125 cubic centimeters. Next one, what is the volume of a cube with a side measuring 9 feet? Okay, so the volume is going to be side cube, which is 9 feet cube, which is going to give us 9 times 9 times 9 cubic feet, which is going to be 729 cubic feet. Triangular prisms, you have a triangular face, and so you're going to look for the area of the base. So the area of the base, how do you tell the base? Let's cut cross sections along the length. I cut a cross section here, cross section here, cross section here, cross section here. I have triangles all the way through. So it's going to be area of the base, which is half base times height of the triangle, and then times height of the prism. What is the volume of the prism below? So let's look at it. The volume is area of base times height. Now, what is the area of the base? It's a triangle, so that's 1/2. The base is 16, height is 5, and then we multiply by the height of the prism, which is 23. So this is going to give us 16 divided by 2, that's 8. 8 times 5 is 40 times 23, and this is going to be cubic feet, which is going to give us 920 cubic feet. Now let's look at this example. What is the volume of a prism if the triangular base has a length of 8.1 meters, a height of 4 meters, and the prism is 10 meters long? So the volume is area of base times height, which is going to give us 1/2 base times height, then times, let's call this h1. So 1/2 was the base is 8.1, the height is 4, and the prism is 10 meters long. So let's divide 4 and 2. So this is going to give us 16.2 times 10 cubic feet, which is 162 cubic feet. Now let's look at trapezoidal prisms. A trapezoidal prism has a trapezoid for its base, and the volume of a trapezoidal prism is area of base times height. So the area of a trapezoid is 1/2 base 1 base 2. We'll call it B1 B2. So this is I'll call this the base 1 here, and this is the base 2 here, times the height of the trapezoid, which will be this right here. And then you multiply by height of the prism, which is this line that joins this face right here, this base right here, with this base right here. So let's look at the volume of the prism below. So the volume is area of base times height. So the area of a base here, we're going to look at the trapezoid, because if I if I have a cross section around here, I'm going to get a trapezoid every time. So that's going to be our base. So area of the base is 1/2 B1 plus B2 times height, and then we multiply by this height of a trapezoid here, which I can call H1. So this is 1/2. This 9 centimeters here is also the same as this one right here. So, which is 9 plus 13 times height is 4. So let's divide 4 by 2. So we have 9 plus 13 is 22, which is 22 times 2. And then our height here is 11 times 11 cubic feet. 22 times 2 is 44, then times 11 cubic feet is going to give us 484 cubic feet. So this is how you deal with volume of prisms. Remember, the volume of a prism is area of the base times the height. Your base is going to be that shape that you get when you do a cross section along the length of the prism. So what you want to do first is identify that base, multiply or derive the area of the base first, and then look for the height. The height is that line that joins one base to another base. So this is all you really need to do for volume of prisms.